Hey everybody, today we're going to do a few more examples of literal equations, and these can be a little more challenging, but that's okay. Let's get right to it. So here we're going to solve for a. A is our target variable, so we need to get it out of this fraction. So let's get rid of this denominator. We're going to multiply both sides by p, okay? And we're going to have pz, or zp, doesn't really matter how you write it, equals map plus n. Again, we're solving for a, so let's get rid of this n. N's almost like a constant right here, so we're going to subtract n from both sides. This cancels. We're going to have pz minus n equals map, or map. And again, we're getting a by itself, so let's divide by m and p. These will cancel, leaving us with a, which is exactly what we want, and then all this. So pz minus n over mp. That's it. Number 2, solving for a. A is in the denominator, which is different from what we're used to, so we need to get it out of the denominator. So we're going to multiply both sides by a, which is weird. We usually don't multiply or do anything with the variable itself, but in this case we have to because we can't leave it in the denominator. So these will cancel, so we have m equals, and then a times all of this. So a times b minus pn, and now we need to get a by itself, so we're going to divide by this binomial, which is b minus pn, okay? This cancels. We're going to have a is equal to m over b minus pn. Okay. Solving for a, again, a is in the denominator. This is very similar to the one we just did. So we're going to multiply both sides by a. So m is equal to a times np minus b. Yeah, they just basically switched some of the variables around there. And then we're going to divide by this binomial, so np minus b. I don't know why I put parentheses there. I didn't need to do that. np minus b, those cancel. So a will be equal to m over np minus b. Okay. Number 4, we're solving for x. So k is next to it, almost like a coefficient. Divide by k. Divide by k. I'm going to show you 2 different ways to do this actually in a second. So x is going to be equal to y minus w over v all over k. You could also do it a different way. I'm going to show you this. So let's say, I'm going to write it again here. So kx equals y minus w over v. So instead of dividing by k, you can think of multiplying by its multiplicative inverse or its reciprocal, which is 1 over k. And you accomplish the same thing. So x is equal to, and you could write it like this, 1 over k times y minus w over v. That works just as well too. Doesn't really matter. And you could also, if you wanted to, you could distribute if you really wanted to, but either one of these is fine. I actually prefer that, to be honest, but do whatever works for you. Solving for a, we want to get c by itself, so we're going to divide by c. So we're going to have a equals b plus d minus r all over c. Okay. Over here we're solving for a, so we're going to do the inverse operation, which in this case will be addition, so we're going to add c to both sides. We're going to have a equals all of this plus c. So b minus d minus r plus c. And that's it. Let me zoom out so you can see all this. There we go. Okay, let's try the next page. Zoom in here. Number 7. So we're solving for a. So we're going to do the inverse operation, so we're going to subtract m from both sides. So we're going to subtract m, and we're going to be left with a equals all this minus m. So b over n minus p minus m. There we go. Solving for x, so we have to get rid of c, so let's multiply both sides by c. So x will be equal to, now c, because we're multiplying, will go in the numerator here. So it's going to be y times c, or c times y, it doesn't matter. Multiplication is commutative, so the order doesn't matter. Okay, we're solving for x here. This looks, oop, I'm the wrong one, my bad. I have to move the camera, there we go. So we want to get x by itself. Now all this is being multiplied by x. This is actually a single term because it's all linked through multiplication, so we can divide everything by this. Okay. C d minus r. So we're going to cancel that out. We're going to have x equals, and we're going to have g over c times d minus r. Okay. Here we got solve for x. This one's interesting. This was confusing to some folks in class, and I could see why. So we're going to, first of all, x isn't a binomial here. So we have a binomial times a binomial. We want to get something in the binomial isolated. So we definitely do not want to do distribution here. So what we want to do is get rid of this first binomial because they're linked through multiplication. So we're going to divide everything by n minus p. So that means these will cancel. So we're going to have x minus m, and now there's no parentheses there. I mean, you could have it there, but there's no need to because it's not being multiplied by anything, equals z over n minus p. And I switched the directions, hopefully that doesn't mess anybody up. And we want to get x by itself, so we're going to add m to both sides, plus m, and we're going to have x equals z over n minus p plus m. Okay. Number 11, we're solving for a. A is right here. We're going to do the inverse operation, so we're going to add c. Okay. A is equal to r minus d over b, and we're going to add c to it, so we're going to put c over here, plus c. Boom. Okay, last one. We're going to solve for a. So we just have to do the inverse operation, which is going to be subtraction. So we're going to subtract m from both sides. So we're going to have a equals all of this minus m. So n over p minus b minus m. Let me zoom out. And there we go. So I hope that was helpful, guys. We're going to be starting rate of change tomorrow. So hopefully this clarifies any questions we had on literal equations. Let me know if you have any questions. Thanks, guys.